Today we're looking at a simpler approach to regression. Easy as 1, 2, 3. So our goal, to develop a predictive linear equation in the form y equal a plus bx, where y is a dependent variable, a is a y-intercept, b is a slope, x is an independent variable, and it looks something like this. We start with having historical data. So here we have 5 months of advertising and sales data, which we are going to use to do a regression. So we want to first identify which variables are dependent, variable y, and which is our independent variable x. Important tip, y depends on x. So the dependent variable depends on the independent variable. The dependent variable is the one that we're looking to predict. And the independent variable is the one that we're going to use to do the prediction. Remember, y depends on x. So if we're looking at these two variables, advertising and sales, we should recognize that sales depends on our level of advertising, which means that sales depends on advertising. So our dependent variable would be sales, and our independent variable would be advertising. Right, so sales depend on advertising. Now, these are our regression formulas, and well, we're not going to go through it this way. We're going to look at a much simpler version. So, skipping right past this. So, we're going to be doing something very simple. We're going to learn nexi xi, then x, then y. So, nexi xi looks like this. N times the summation of xy minus summation of x times summation of y. So, nexi xi. Then x. So, then x means our second equation will only be with x, no y's. So all the y's will be replaced with x. So we're going to have n times the summation of x times x, which is x squared, minus summation of x times the summation of x. This could be written as summation of x all squared, but this is also fine. And then for the third equation, we're going to replace all x's with y. So nexi xi, then x, then y. So we should have n times the summation of y squared minus the summation of y times the summation of y. So now we have our equation, should be in the form y equal a plus bx. And we need to find the values of a and b in order to complete the equation. So b is simply the result from equation 1 divided by the result from equation 2. To find a, we start with the averages of y and x. So y equal a plus bx, but we're using the average value for y and the average for x. And since we want to solve for a, we're going to transpose to make a the subject. So bringing over the bx, we shall have the average for y minus b times the average of x will give us a. Or simply put, a is equal to the average of y minus b times the average of x. So these are our equations. So let's go. So we have x and y, and we'll start by totaling these columns. So the sum of x is 1,600, the sum of y is 1,359. Since we have totals, we might as well just find the averages of each of these, since we'll need them for a. So the average for x is 160 divided by 5. That gives us 32. The average for y, 1,359 divided by 5, which gives 271.8. So we now have the average of x and the average of y. So we'll go back to nexi xi. And the first thing we need is a column for x times y. And all we're doing is multiplying each x value by the y values for each row. So 10 times 84 gives us 840. 18 times 155 gives us 2,790. And likewise for the others, till we have a total of 53,786. So n, which is 5, multiplied by the total for xy, which is 53,786, minus the total for x, 160 times the total for y, 1,359. And that gives us 51,490. So that's equation 1. Equation 2. We have n times the total for x squared. So this means we need a column for x squared. And all we're doing here is squaring each x value. So 10 squared gives 100. 18 squared, 324. Likewise, till we have a total of 6,438 for the column. Here you go. So n is 5 again. 5 times 6,438 minus 160 times 160, giving us 6,590. At this point, we have enough to find b and a, because b is equal to the result of equation 1 over the result of equation 2. So here goes. Right, so we don't know equation 3 as yet, but we don't need it as yet. So b is 51,490 divided by 6,590, giving us 7.8. A is equal to the average for A for y minus b times the average of x. So the average for y was 271.8 minus b 7.8 times the average for x, which is 32. And this works out to be 22.2. So we now have the values of a and b, and we can write our equation. Y equal a plus bx, so y is equal to 22.2 plus 7.8 multiplied by x. So sales is equal to 22.2 plus 7.8 multiplied by the value of advertising. So this is our equation. Next, we want to do a little bit more. We want to do our correlation coefficient. And this one requires equation 3. So here goes. So we need a column for y squared. In this column, we're just squaring each y value. So 84 squared is 7,056. 155 squared, 24,025. Likewise, until we get the total for the column, which is 453,769. And we can now say n, which is 5, multiplied by 453,769, minus 1359 times 1359, giving us 421,964. And this is value of equation 3. So, equation 1, 2, and 3. And we are to find our regression correlation coefficient. So the value of equation 1 divided by the square root of equation 2 times the square root of equation 3. So 51,490 divided by the square root of 6590 times the square root of 421,764. We could also have used one square root sign and just put the multiplication of 6590 and 421,964. Either one works. But this works out to be 0.98. So you can check your calculation and see if you get the same thing. So at this point, we have come up with a regression equation, y equal a plus bx. I will now have the value of our correlation coefficient. The last thing we want is our coefficient of determination, r squared. And for this, all we're doing is squaring the value of r. So 0.9 squared gives us 0.9604, and we usually express this as a percentage. So this is it. Regression as easy as 1, 2, 3. Simple steps to answer all the questions. Alright, take care, all the best.